Hi, this is John Block of Mr. Block Tutors Math. And today we're going to look at substitution and how we use substitution in math as a technique to make things easy and to figure things out. Let's get a whiteboard here. Here's a simple example of substitution. If I have 7x over 3 equals the quantity a to the fourth plus 1 cubed, and you're asked to find x if a equals -1. So substituting means all you do is take that -1 and plug it into a and work it out. So I've got -1 to the fourth, and I know that -1 times -1 times -1, the two double negatives cancel each other out. 1 times 1 times 1 times 1 is 1. 1 plus 1 is 2. 2 cubed, which equals 8. And back to this side, 7x over 3, multiply by 3, I get 7x equals 24, so x equals 3 3/7. Simple example of substitution, you all are aware of that. Now let's look at let's just get a little bit harder each time, or not harder, but this equation comes from a story problem about electricity, where you've got a circuit that has parallel sets of resistors, and resistor 1 is 10, resistor 2 is 25. Well, obviously, here's another easy case of just plugging in the numbers. So 1 over 10 plus 1 over 25. I do want to look at this a little bit, though, because notice what happens here. We need a common denominator of 50, so 5 times 5 and 2 over 2, and we end up with 7/50. Now the question is, what's R here? Is R 50? Is R 7/50? Is R 57ths? Is R 7? What is R? Well, there's a little trick in math. It doesn't have anything to do with substitution, but it's a little trick when you're working with fractions, that if you have a single fraction on each side, you can invert both of them and your equality will be maintained. So I could invert both of them. I get 7/50, or I think that's what, 7 1/7, 7.14, something like that. Now, notice on this that there's our answer, but notice that we couldn't have flipped these right away. Like, you could not just invert all three fractions and get R equals R1 plus R2. No, you can't do that. You could put the other side, the right side, together, and I'd have a common denominator of R1, R2. And if I had a common denominator R1, R2, then I'd have to multiply this by R2 over R2, and multiply this by R1 over R1, and I'd have this. Now that I've got a single fraction on both sides, now I can flip them over and get R1 times R2 over R1 plus R2. You could try that. Try plugging in your 10 and your 25 into here, 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 and here, and see if you do, and you should end up with 7 1/7 in that. Now let's look at something a little bit more than just simple substitution. At first, this problem looks like a 2 equations, 2 variables problem, which is substitution is very useful in solving those. But actually, it's kind of a fake problem, a fake substitution problem, or fake 2 variables problem, because if I add the 3 to both sides, I get y equals 8, and then I simply substitute my 8 into y, and I end up with 8x equal minus 3x equals 20, and you can see x would be 4. That's a fake problem, but let's change this a little bit now. Let's take this out, and take that out, and take that out, and let's slip a y in here. Now we've got a real not a y, an x. Let's slip an X in there. Now we've got a true two equations in two variables problem. And here's where the power of substitution comes in. Because all I have to do is take this one right here, this equation, and move that x over by adding an x to both sides and get 5 plus x. Then take that 5 plus x and substitute it into y. So then I get x times 5 plus x minus 3x equals 20, which gives me 5x plus x squared minus 3x equals 20, which gives me, we should be thinking, uh-oh, this looks like a quadratic. So I should try to get the form ax squared plus bx plus c equals 0 in order to solve that. So I've got x squared plus 2x minus 20 equals 0. Looks like it doesn't factor, so you would use the quadratic formula where a is 1, b is 2, and c is negative 20, and negative b plus or minus square root of b squared minus 4ac all over 2a. And you can do that. Plug your 1 in here, and plug your 2 in there and there, plug your c in, and so forth, and see what you get. Another example of substitution, and this is the key there, is that we solve one of the equations for one of the variables in terms of the other variable, and then stick that back into the other equation, which gives us one variable only, and then we can solve that. Now here's another example of the two equation, two variable system and using substitution. And a lot of times people would do something like this. They would say, okay, I'll solve for x on this one. So they'd have 3x equals 10 minus 2y. Divide the 3 out. And then they would take that 10 minus 2y over 3, plug it in for x. Oh, a cumbersome problem. But there's really a lot easier way to do that. Look what we could do. We could look at both of our equations right here and say, well, it looks like they both have a 3x in them. They both have a 3x. So let's take this equation right here, solve for 3x, not x, but 3x. Now then replace this 3x, or that whole 3x with 5 plus 3y. So replace the whole 3x with 5 plus 3y plus 2y equals 10. Take the 5 across, or subtract 5 from both sides, get 5, 5y, y equals 1. X equals, and now I can go back to any of my beginning equations, my two beginning equations, and plug in the y equals 1. Well, let's take this one for instance. So 3x plus 2 times 1 equals 10. That's 2, so 3x equals 8. X equals 2 2/3. And there's x equals 2 2/3. Okay, now let's look at how substitution is used in functions. So here I have the function f of x equals 7x squared plus 3, and I have the function g of x equals 2x minus 9, and they want me to find g of f of x, g of f of x. I think, wait a second, I'm not wrong here. This should have been a 2. G of f of 2. So what I do is I find f of 2, and I find f of 2 by substituting. So I take f of 2 means wherever I have an x, I replace it with a 2. 7 times 2 squared plus 3. 2 squared is 4. 4 times 7 is 28. 28 plus 3 is 31. And then I take g of that result. So I do this first. I take f of 2, and then second, I take g of that result. Well, g of 31 is 2 times 31 minus 9, which is 62 minus 9, or 53. Now, an interesting question would be, back to my original mistake, what if they would have said instead, find g of f of x? Well, it's just another substitution problem. You look at g of x and say, well, what is g of x? It's 2 times something minus 9. Well, what something are they wanting us to put in there? They want you to put f of x in there. 2 times f of x minus 9. And what is f of x? Well, f of x is 7x squared plus 3 minus 9. So distributing that 2, I get 14x squared plus 6 minus 9, which is 14x squared minus 3. Now, notice something interesting. That's what g of f of x is. Now, using that idea that we just found, or that expression we just found, then what would g of f of x of 2 be? It would be 14 times 2 squared minus 3, or 14 times 4 minus 3. 14 times 4 is 54 minus 3. 56 minus 3, which is, again, 53. Same number we got over here. Now, in this problem, they're giving us that a over b equals 4, and then they're saying, what is then, if a over b equals 4, then what is a squared minus 16b squared equal to? Interesting problem. What are they really asking for? Well, remember, if we're talking about substitution here, let's take and solve for a in this problem and get 4b. And then let's take that 4b and substitute it into a squared. So a squared becomes 4b squared minus 16b squared. 4b squared is 16b squared minus 16b squared. Isn't that interesting? Answer 0. What if we would have gone about it a different way? And what if we would have solved instead for b? Like brought the b over here and divided the 4 out, then b would equal a over 4. And now we'll take a over 4 and plug it into a squared minus 16b squared. So we'll take that a over 4 and plug it in here. Now we get a squared minus 16, a over 4 squared, a squared minus 16 times a squared over 16. The 16's cancel. A squared minus a squared is, again, 0. So I've tried to look at some different uses for substitution today. And you can find more interesting math videos at Mr. Block Tutors Math. And also, if you need help building some skills